Sorry, I think I didn't. Oh yeah. So now I think I'm audible. Wait. Yeah. So this is better, looking better as well. So today I'm solving that kind of a project. I have kind of completed some parts of the project, but I will show you what is the uh, what commits I've already completed and what we will be completing in the future. So here I have a project structure. So what is going to happen is I am going to ingest data from Google Cloud, and then we are going to do some transformation on the data set. As it is NLP, then we might have to remove white spaces from the text. Other Also other kind of transformation we might have to do. We will be doing that, and so so this is the general folder structure of my projects that I have. So in components here, I do have data ingestion, data transformation, model evaluation or evaluating models, model trainer, model pusher, and configuration basically for if you are importing data set from cloud data uh, data warehouse like S3 or GCP Google storage, or maybe Azure blob storage. Here in constants there will be some constant functions for maybe importing for file handling and utilities. And then there will be a folder called as entity. Uh, there will be config entity and artifact entity. I will explain it in detail further. Then there will be exception handling and logging, and there will be, for this particular project I will be having two pipelines: prediction pipeline and training pipeline. uh, there will be utils. Yes. So as we will go forward with the project, I will be explaining whatever the components there will be there in the project. So first of all, I would like to go and show you how I created all the basically through commits in my GitHub account. I will be showing how I created the folder structure and exception handling and logging I've done till now. So, so yes, so this is my GitHub profile. So hope you can see it, and I have some tabs open, but like just ignore, please ignore it. Actually, I will do this. It is better. So in my repositories, I have this hate speech classification project, and the data set for this project I have got it from Kaggle. On Kaggle, if you go and in data sets, basically, if you search hate speech, um, in data sets, any hate speech data set you can take. This one has 193 votes, so probably this is a good one. So the data set will something look like this, and 7 columns. Yeah, so in I think here or the tweets they are basically carrying out whichever the if there is offensive text, then they will give a particular class name called speech. One is off for offensive. Hate speech is for offensive. Then sorry, zero. They will be. They are doing, I think, uh, encoding and giving classifying based on categories of. For example, here they have given a zero encoded zero to classify a class where the tweet is from having hate speech. Then they are classifying between offensive language and neither. So they I think these in this example they are doing multi-class classification. I and let me read out the data. Data set using Twitter data is was used to research hate speech detection. The text is classified as hate speech, offensive language, and neither. Due to nature of study, it is important to note that this data set contains text that can be considered racist, sexist, and homophobic or generally offensive. So yeah, so they have basically given numbers. I think this could be like easier to classify because they have already given classes. I don't think I have taken such a data set. I have taken a data set where you have to like on your own you have to classify data on your own. I'm a bit I should have kept this file open, but okay, it's fine. This is the first stream, so these things are bound to happen. So this is in a zip file, and I will show you how the data looks. So this is how it looks. And basically the first column is ID. Wait, um, I hope this might be visible. The first column is ID. I think we have around 31,000 to 32,000 rows here, so it will be like 31,000 to 32,000 tweets. Then there is label, and I think the classification is uh, yes, it is if it is if it contains hate speech or not. So it will be like 0 or 1. So and these are tweets which are text prompts. They have added like For example, if you even on Twitter or Instagram, you're doing like if the users are commenting, then they will include hashtags. So here, see, they have included hashtag disappointed, hashtag get thanked. So this seems like a pretty like real world data set. So on this data set I'll be working, and let me also check the second data. Yes, so I think I have done this. Is similar or another, like this is a raw data from which I have gotten out the imbalance data, which is basically um, there are like different classes, and I think I'm going to consider only one class for simplicity and just solving this particular project. So what I'm doing is I have considered hate speech as a column and offensive language, and neither I have removed. So that the data, whatever was there, uh, that particular data only I'm using, I think. But for my simplicity, I have removed other columns that are there than uh, other than hate speech. I have removed them. So now here in it is easy. For example, like whenever you are trying to understand a particular project, for example, if I go to GitHub, Microsoft, it is very easy to understand someone's repository. Just that it depends on if you are ready to work or not. For example, Microsoft has a very good repository that I know called as NLP recipes. Um, let's check. Why am I doing this? Wait, I have it starred, I think. So this basically what I'm trying to show you is that how, yeah, this one. So what I'm trying to show you is how to, understand how they have built the project from the beginning. So many of the commits might be cancelled. They could have been, overwritten by another code to overwritten by another by better code. So it is fine, but at least you can understand what code was written earlier and how the development of a particular repository or a project has happened. So in here, this they see they have even archived this, so I don't think it is in use. It is now only a read only repository, but still um, it is worth checking to learn how how to merge and learn about GitHub and GitHub commits and how every role works. There, I think there could be different branches as well for different contributors. So similar in a similar way, this is my project, and what you do is go to commits. Over here, I will go and check my initial commit. You go on the commit, and basically here, whatever lines that are there, these are the files that are added, and whatever lines that are there in green were added because I built the when this particular commit has happened. So this was the initial commit. So this was like, it's not like I have written any of this code. This was like, if you have to, if while creating a repository, you have to choose that if you want to include a license or not, if you want to include git ignore or not, if you want to add a readme. So I added a readme with hate speech classification as a heading. Then I added MIT license, and then I added a git ignore so that I could keep the uh, virtual environment file away, like out of the git commit. So let's go to the next commit. So here I'm trying to add folder structure. So in this particular file, I will tell you what has happened. So I'm not going to run this because maybe in some other project I will show how, you know, I have created the folder structure, and even on Google or somewhere you can find how to create these files. What I'm interested in these three files. This is requirements.txt, setup.py, and template.py. Not this one. I think this is okay. Um, okay. 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 So in this, what I have done is, first is the, yeah, so requirements.txt and setup is also empty. So I basically, I don't have to look into anything here as well. In on top of the all the files, I can see that there is written plus 57 in green plus, and minus 0 in red. So whatever the plus 57 in green is, whatever number is there in green with a plus sign, that number of lines you have added to the code, and whatever the number is there in red with a minus sign, that number of lines you have removed from the code. So basically what I have done is I have added a template.py file where I have imported OS from, then imported path from pathlib, imported logging. Uh, Logging, I have made a simple logging string with ASCII time and a message. Then I've created my project name, which is hate speech. You can use any project name, maybe like image classification or anything you want. Then this is what I've done to create folder structure. This is basically gives you list of files. I know that some might think that, why am I explaining these things? Because this might come under machine learning operations and not just data science. Data science could be said that you have to just build a model. This these all things can come under machine learning operations, but I think that, it gives you an edge if you know these things while you're learning. And like, I want to practice these this kind of uh, project where I mean, I have done a lot of them here. I have, like, in Python projects, I have like how many, 38 items, and all of them are different projects, including some of them are like data engineering projects, but others are this is a recommender system, this is uh, chatbot. All of them are like data science based and AI based projects. Uh, just that like I have made it in a modular way, and uh, which could be a part of machine learning operations, but it doesn't hurt to learn these things because at the end, if when you have a data when you have to do a data science project, what is important is you package the data science like the machine learning model in a web application and then deploy it on the server. So that's why these things are also important, and I think I will come to that after while I am discussing CI/CD deployment and everything. Right now, we will concentrate on creating the folder structure. So while creating the folder structure, what I've done is um, in using f strings, I have project name is this variable, and using f string, I have given address to every file and folder that I want to make uh, in my root directory, and put it in a variable called list of files. In a list of files. Okay. So I am having components. In components, you have to create uh, you have to create like Python files like data ingestion, data transformation, model trainer, model evaluation, model pusher. Then in configurations, I've created a file for Google Cloud Syncer, which basically imports data from Google Cloud. We can do this project without this file as well. In fact, I would not be showing you this because I'm not having a Google Cloud account, but I will show you how to like write code to import and update whatever data you have got from your Google Cloud storage. You ingest it, and how if you update the data in your local storage, then how to move it back to Google, update it in the Google storage as well. The, okay. So in every like file or folder you make, you have to make a constructor file, which is underscore underscore init underscore underscore dot py to uh, initialize basically. So you can add a class. So it basically the constructor file basically gives the initial state of the initial state and attributes of the class or in a folder. So other than that, I'm also adding app.py. This demo.py file will be there to test uh, whatever code we have written, for example, login code and exception code. Here, I have also added requirements.txt, Docker file, setup.py, and Docker ignore. Further, you can I I have written a loop called where file path in list of files, for file path in list of files, file path is equals to path file path. So basically, this is what I'm doing is who is dot yes. So basically, I'm distinguishing between what my file names are and what my path is. Over here, here it splits the file directory, basically for file location and the file name. So this init.py is going to be a file name, or model.py is going to be a file name, and hate speech slash ml is going to be the file path, a file directory. So here, what you want to do is so yes, basically this is deciding if there is a file directory or not. If the file directory is not there, then you need to create a file path, and then for a particular file name, which would the uh, whatever I said before. And if there is no file path, or yeah, in this particular if statement, what I'm doing is, if there is no file path, then you want to create it in the root directory. Basically, that's why this if statement is I've written the this particular if statement. Logging exists. Okay, so I think we have understood about this commit. Let's go back. Now, I have changed three files where I have added readme. I have updated my readme. Project workflows is basically how you will follow if you are changing something in the project. You will first go to constants folder, and then modify the constants, then go to config entity, then go to artifact entity, then components, then pipeline, and app.py. Here I've added how to run the project. So here, first you want to create is what you want to do is create a virtual environment. For this, I'm using Conda. You need to have, I think, Anaconda in your installed in your PC before using Conda. Uh, Other thing you could use is also a mini Conda. It is a lightweight software than Anaconda if you don't want to use Jupyter Notebook in your system. So Conda create uh, Conda create new hate Python Python version 3.8 with a yes flag, and it will create your hate virtual environment, and I will show you how you can check if the environment is uh, created or not. Okay. So using Conda environment list, you can check what are the Conda environments available. So there is base, and these are all the environments that I have created before. There is this hate I have created, and it is using mini conda itself. Okay, so I will activate it. So right now we need to use the uh, command conda activate hate. So let's activate conda activate. Okay, so conda like hate is activated, so we can work in this particular folder right now. So then what you want to do is, before running the pip install requirements.txt, you want to write whatever requirements you want in whatever libraries you are will be requiring in the for this particular project. So I'm including some of the libraries that are there. We'll be needing NumPy, Pandas, TensorFlow, Matplotlib, Seaborn, NLTK, regex for a regular expression, uh, scikit-learn, Google Cloud Storage, Fast API, UVCon, Jinja, and this basically hyphen e dot makes what the particular this particular folder itself as a package, and so that if I uh, add for example, if I completed first version of the project, then I deployed it, and then I felt that I want to, there's a better library that is there, or there is a better model which is there, and I have to install a library for that particular uh, model. Then like I can add it to requirements.txt, and it will be, I need to actually revise this. Sorry, let me just check if I'm audible. Okay, so this looks good. So I will be actually coding as well, because now it will take a lot of time to explain everything right itself right now. So uh, also you have to like write this a setup file, setup.py file to link your email ID and who is the author, and maybe the version of the project that you're writing, name of the project. Okay, yeah. So let me explain. Just check once. Why am I doing this? I should let's get educated together. Why is hyphen e dot used? This is, I think, called wipe coding, when I mean, wipe coding is something different. You use AI, but right now I'm just trying to, in, Okay. Wait, I need to be detailed in a requirements txt file. Let's see, what does towards data science has to say. No, I don't want to. Hmm. Well, I think we need to go to AI. Okay. Why is I don't know. I let's okay. And this is okay, I think. No, no, I think I need to know. Why is hyphen e dot used in requirements? So file means install the current project in editable development mode. Okay. So in an editable install, your project source code is not copied into site package. Instead, a link is created to your local project directory. Any code changes you make are immediately reflected without reinstalling. Okay. Okay, okay, okay. So yeah, basically what I think is happens is if we use hyphen e dot in requirements dot txt, then our entire project is also installed as a package, just like other packages like NumPy or Pandas. And if we make any changes to our project, then we don't have to again like install it. For example, how the libraries work when we download them as a version. Uh, in a similar way, the changes that are made in the project work without installing the package again and again. I think that is what it means. Okay. For now, it's well, I mean, it's not rocket science. So in this setup.py, I have called my project. Oh, okay. Requirements are logging an exception. So for logging an exception, what I did is I went into the hate speech folder. In the hate speech folder, I went to logger, and in this particular file, I created logging. So first we have to import logging, then OOS, and from root and date time. I think for the first time I didn't. Yeah, and date time we will need to get whatever date or time is there. So this is a f logging f string I have created, and how uh, the logging this statement is for where you want to uh, store the logs. So what it does is it gets the current working directory and creates a logs folder over here. This is the logs folder as I've run it before. I do have some logs, and it will basically create a log file with the name of uh, with, with the name of the date time that will be there. For example, this file was created on 9th of December 2025. Yes, okay. So, yeah, here you are making using log path. We are creating the mm, directory, and which will include a logs file. And this is logging basic config, and this will be there on if you search for Python logging. Here you can get how to write a logging file. Yes, see the same this is the same file path that is there. Instead of library, I have hate speech, then logging, then init.py. In init.py, I have written the code for logging. This is, I think, their application, and when they want to run this code, then when they run this code, then the log is created. That's what they are trying to do, I think. Okay. So using that, you can. Yeah, here I was just testing the logger. So in logging basic config, you have to give some for variables. You have to give file name, format. It will be like ask current time and name, then level name and message. I will show you how it will look in the logs. So this will be the current time, ask current time, then root info. Welcome to our project here as well. I will go welcome to our project. Okay, these are empty logs. I'm not sure why. Okay, I think we are done with logging. Now we'll go to exception handling. So for exception handling, basically, what I'm trying is we should get a clear error message that we will be having. So that is what I'm trying to do here. I have imported OS systems, and then for error message, I have got it from online from the web, how to pass except if there are exceptions, and how to display them. So basically, what I'm trying is I am trying to get so that if I get a clear error message, then I get it in a clear fashion. Actually, what I was going to do is I had created a false demo. In this demo file, I had created a false a error, basically a division error, no division error, where you divide something by zero and it will give you an error. So I had created, but I can't see the logs right now. I will check if it is there in the. I don't think it will be there. No, it is not here. Okay, no problem. But yeah, I mean, next time I will show how to create it from scratch. So I have done the uh, how to get data from Google Cloud as well. But for now, we will move forward to writing experiment notebook, and let's keep it for later. Okay, so this looks fine. Sure. Okay. For project notebook. So first, whenever you are like building a project, first you will write the entire data science project in a experiment notebook. Um, okay, wait, I have to. Am I audible? Yes. For logging an exception, what I did is I went into I need to increase my volume because it is not getting recorded clearly. So I will be now adding the notebook, and then we will understand. Okay, experiment notebook, and then we will understand how to. I'm doing is I'm in it is not visible right now, but what I'm doing is I'm going to hate speech folder. I'm making a notebook and I'm adding the IPYNB file experiment notebook that I have created. Okay. Mhm. Yes, so here I think if it is visible, I have in the notebooks, I have added this experiment. I shouldn't have named this in this particular manner, but it, okay, okay, this is better. So here I am using some GPU, but what is the gist of this is that I am basically connecting with a GPU, but it is fine. I will explain. First, you want to unzip the dataset that is there. I actually did perform this on cloud notebooks, so that's why the address is not matching Google Cloud notebooks. Um, Google Colab notebooks, so that's why it is not exactly matching, but I will still explain how it is working. So first you import imbalance data here. I could change this to data Python environment. It, I think I made a mistake. I think I shouldn't have called it before, you know. Wait, I noticed this dot. Okay, yeah. So import OS, unzip data. Okay, wait a minute. Even if I try to run this in uh, my local environment, it might not run. That's why I am trying. Otherwise, I will just go and do it in a Google Colab. Hate speech, hate speech, hate speech. Speech. Mhm. Okay. Okay. Let's see if this works. First, I am. What happened? Uh, uh, Let me open display. Sorry about this. Okay. Um, and this has become a little unplanned, but okay. So that's why the I will add the data zip to this file, and it will then run. For now, I will comment this. And these things actually happen while you are in different environments. You have to change some things and make sure that the data is there. Since I am using some GPU, that's why I have to do this in Google Colab. Otherwise, I could have done it on my PC as well. Let's check this out. Okay. Okay, so now this should run. Yes, success. So it has basically unzipped the files, and we will check it by. Okay, so now let's check imbalance data. So for starters, we will do some uh, exploratory data analysis. Exploratory. This is how the data looked. I had shown you in Excel file. This is the same data set, and I can actually do this. Yeah, okay. So first we will do some exploratory data analysis. For that I'm importing Seaborn. Then what I'm doing is making a count plot to know how many values are there that are containing hate speech and that are not containing hate speech. Uh, you could calculate this with, yeah, 0 is for no hate speech and 1 is for hate speech. Okay. And imbalance data shape. Okay. The rows are 31,962 and columns are three, which is one is ID, other one is label, and the next last column is tweet. Okay. So this could you can do this using another value counts. Label dot value count. I hope this works. Maybe it is. Okay, I think I have not imported pandas, and my syntax is different as well. Different. Still, it will not work, I think. Okay, pandas is there. Oh, I think in Google Colab, I think, yeah, I had imported pandas. Yes. Okay, so this is a better way, or like since we have less number of columns, this is a easier way to know. So I think 2,200 values are there which contain hate speech. Okay, and let's check if there are any null values. No, and no, there is no data where there are null values. So I think we'll drop the ID column. So now we'll have two columns, label and so this I am storing in raw data file, raw data CSV basically. What? I'm a bit confused. Okay, okay. So I'm just reading this file. I thought that I dropped the column and did something and happened. No, no, no. Yeah, I'm right. Okay, raw data. Let's check the shape of this file as well. 24,000 values are there and seven columns. We are checking if there is any null values. No. So let's drop the columns which are not required for us. Which one in raw data? I think we don't want unnamed. Unnamed is the column. I think in place if we don't have ID, it adds the unnamed column. So that is because if I go here and check, I don't think there will be any unnamed. Okay. Oh yeah. So this is the ID column. If you don't have a name, then it will. So we have dropped a name, count, hate speech, offensive, and neither. Um, named count, hate speech, offensive, neither. Okay, so we just want class and tweet. Okay. Let's check for unique values in the data sets, raw data, class. So basically, we are trying to get what are the different values there in the class, distinct values there. So for this as well, we are doing this similar thing. We are getting a count plot for class, and yes, I think this was the data set that was there. We were checking. So class 0 is for hate, class 1 is for abusive language, and class 2 is for no hate. Yeah. Okay, let's copy the values of class 1 into class 0. Okay, raw data class is equals to 0. Yes, I think so. These are, you can say that there are some offensive words here. So this is the target class, I think. Okay, so what here I have done is basically clubbed class 1 and class 0 so that both of them to mix them, to merge them, uh, and combine them as hate speech. Has been over an hour. Um, okay, so here I'm replacing the value of class 1 and class 0 so that 0 class will be given to the tweets that don't have any offensive text, and 1 will signify that it has offensive text. This is correct. Classes 1 and 2. Now plot. We could have actually. Okay. So 1 is. This could have been done in more simpler way, but for now it's fine. Okay, I think this was basically explanation of how the imbalanced data was created. Wait a minute, I have to take call. Okay, am I audible? Yes, I think so. So I think since the data was less, it's around I think 31 to 32,000 values. We have combined two datas over here. Even I was not understanding what was happening at the beginning, but now it is clear. Okay. And this could be a case, for example, if there are two sets of places that you are getting your reviews. For example, there is a airline company that you are so if someone has a complaint with their ticket or maybe their travel uh, that with their trip that they had with a particular airline, then what they can do is they can go to Twitter and then tag the particular airline and say that we didn't have a good trip, and whatever review they want, that could be a particular that could be a data set you would want to work with. Also, other than another review data would be in every whenever you book a ticket or you get boarding pass, or after completing you get an email that generally companies do this to no in for example, if you are getting a product from or a food purchase you're doing, for example, on a Deliveroo app, or maybe in India there is a Zomato app for food delivery, or from Amazon you buy something, then whenever the product reaches you, it will ask you that if you want to give a review. So one data set could be from their own customer reviews, whatever they have bought, that uh, uh, even the Twitter reviews would be their own customer reviews, but this one would be their home channel, and Twitter is a social media channel. So that's why I think they have used here we can see that combining of two data sets has happened. So okay, okay, so we have completed EDA, and we will now go to pre-processing. I don't think I will have time for everything right now. I think we will just go through the experiment notebook and then we will end the stream here. Excuse me. Wait, let me get. Okay, so the pre-processing, what I'm doing is this is regular expression, then NLTK, then we are importing string, then NLTK dot corpus import stop. We are importing stop words. So we will be downloading all the stop words that are there. Stop words are basically whenever someone is saying a particular sentence, then there are words like are and are like whichever the words that are not defining a particular review that are there, that are stop words. I will show you stop words. So yeah, so the stop words over here are something like a is in and stop words in and yeah, same. Stop words are something like the, is, and that are often carry little meaning for text analysis. Um, yes, so these are what we want to download so that we can match and remove them from our reviews. So right now we are applying stemming and stop words on the data. So we are using snowball stemmer English and stop word is also English. So let's apply a regular expression and do some cleaning. Um, so this is just like a function that I'm writing for cleaning the words. So in data cleaning for each and every word in a statement, what it will do is tail words is equals to string dot lower. I want to know. Yeah, this is string. Yeah, I wanted to know if make sure that str is string. So what I'm doing is converting all the letters into the lower case, and I want to check. Okay, so I think I will have to end the stream or maybe go. Okay, so I think I will have to pause. I don't think I will pause it, but I think, shut the camera. I am back. I am back. You could say that I was on a break for like, I think it has been a long time, but it's fine. Let me make sure everything. Okay, so here, I think we were writing a data cleaning function, and so you convert the words to lowercase, then we are using a regular expression and removing slashes, brackets, asterisk marks, question marks that are there from the words. Then we are, if there is any links or anything, we are removing that as well. काय पाहिजे? So finally we can do this. Um, I think yes. So in this we have removed all the exclamation marks, then converted the entire text into a lower case, removed the column hashtag, then removed at the rate symbol. Okay, so this function is working. And here what we are doing is we are uh, defining x, which is the data, which is the independent variable or explanatory variables, and y, which is the target variable or dependent variable, which is the label column having 0 and 1 values for basically to classify the tweets. Next, we will I am importing taint trace split from sklearn modern selection. And here, let's split the data into xtrain, xtest, train and test cases. Okay, so training cases, training data, I think this is 50,000 out of 50,000. This is 30-70 split, I think. So now we will do some feature engineering. Isn't this working? Is there anything wrong? Chart, we had open chart repeatedly. Okay, it says that these two lines are all come. Array channel. So it says that these two lines are old inputs, and you might have to change it. Okay. TF. Okay. I don't want to make a lot of changes, so if it works, then I will keep it that way. Let's see. Second one is fine, I think. Okay. Max words is 50,000 and max length is 300. Tokenizer is equal to number of words, max words, tokenizer dot fit context extreme. What will the tokenizer do? Okay, this is just like this is basically just like model, I think. Uh, so we have tokenizer. We are fitting the tokenizer on our text, which is there in X, which is the training data, and then we are getting sequences using tokenizer. Uh, dot text to sequences. Then sequence matrix is equals to paired sequences. Sequences comma max length. Okay. Sequence matrix. Okay. Import sequential keras dot layers. So I think here we will be constructing our own, or maybe editing the um, mm, inbuilt models using layers. So we are basically importing activation functions and uh, different layers and LSTM model. From Kira's optimizers, I'm importing RMS prop. Yeah. So below I have created a model architecture. Here model is equals to sequential. Then model dot add embedding max words is equals max words comma embedding. In embedding arguments are max words comma 100 input. We can also like check uh, yeah, by hovering over it we can also check what is the um, what are the arguments there in embeddings. So I think the um, arguments are input dimensions is max words, then output dimension is 100, then input length is equals to max length. Maximum length is, I think it was something. find over here. Oh yeah, 300 and max words is 50,000. So then we are using spatial dropout. So we'll understand now what is this. This layer performs the same function as dropout. However, it drops entire one-dimensional feature maps instead of individual elements if adjacent frames within feature maps are strongly correlated, as is normally the case in early convolution layers. Then regular dropout will not regularize the activations and will otherwise just result in an effective learning rate decrease. In this case, spatial dropout 1D will help promote independence between feature maps and should be used instead. So I'm using LSTM. Sorry. So I've kept the dropout to 2. Units is 100. Activation is tan h. And recurrent activation is sigmoid. Okay. Okay, let's run this model and then see. These are the results I have got. Okay. Was it not connected? Start model training. Let's see if this works. So history is equals to a model fit. This might take some time. We are using a GPU, but let's make sure that it works. A model.fit uh, sequences matrix while underscore train batch size equals to train batch size is 128, epochs is 1, validation split is equals to 0.2. Let's see. And since this is model training, I had given a recent interview in which the interviewer asked me about a question that if you want to increase the speed of model training, then what would you do? I mean, of course, it is to be considered that you don't want to uh, compromise on the results. So, keeping that in mind, how will you improve the training speed? So, let's try to check how can you improve model training time in neural network without compromising output or accuracy. Improving training time of a neural networks without sacrificing accuracy is a very common interview question and real world ML question. So let's see. Data level optimization often better data pre-processing, normalize and standardize inputs, remove constant or highly correlated features. Okay. Use feature selection. Okay, so remove constant or highly correlated features. Basically, what it means that uh, if there is high correlation in two features, it is anyways going to be problematic for prediction. And other than that is that like um, highly correlated features will if you apply them individually, then those will tend to give similar results. So it is better that you include a single one of them instead of including multiple highly correlated features. Use feature selection or embeddings instead of raw dimensional inputs. Okay, so that's what we are doing. Fast, cleaner inputs, faster conversions. Okay, efficient batching. So use mini batch training instead of full batch. Choose optimal batch size, often 32 to 512 depending on hardware. Too small, noisy gradients. Too large, slow convergence. Okay. Model architecture improvements, no loss in accuracy. Reduce unnecessary depth width. Many networks are over parameterized. Okay. Use fewer neurons per layer. Bottleneck layers. Use bottleneck layers. Use depth-wise separable convolutions. Okay, same performance, fewer flops. Okay. Use better activation functions. Prefer ReLU, leaky ReLU, GEL, GELU over sigmoid or tanh. Okay. Avoid vanishing gradient problem. Okay. LSTM would be useful to avoid a vanishing gradient problem. Faster conversions. Weight initialization. Javier or HE initialization prevent slow early training and unstable games. Okay, there are a lot of solutions. I think training strategy optimization, learning rate scheduling. Start with higher learning rate, then decay. Okay, use step decay, cosine annealing, reduce LR on plateau. Fewer epochs needed to reach optimal accuracy. Okay, adaptive. I think this much is fine. Well, in interviews, I mean, it depends on what level they are asking you. You also make sure that you they are not asking about GPU, but you want to give correct answers. Okay. Okay, this is completed. Test sequences is equals to token. Okay. We are passing test sequence, creating test sequence and test matrix as well. For model evaluation, accuracy is equal to model dot evaluate test sequences test sequences matrix by test. Is it okay? So basically, yeah, correct. Okay, I understood. So y test is basically mhm. So yes, this test sequences matrix is based on X values. So testing. Wait. Okay, sequence matrix Y train. बरोबर है. This is correct. Sequence matrix is basically training X train values, and X train values correct. Y train is basically the prediction, that is label column, and based on this data we train the model history. Then here test sequence is equal to X test correct. Test sequence matrix. Okay. Yeah. Model evaluation is a test sequence matrix and Y test. Okay. So I think what we are getting is here a basically a evaluation. Let's see. I don't want to. What have they done with history over here? You're fitting model. Model dot compile loss binary cross entropy. Okay. So where am I using history? Find history. Okay. Where is second one? Huh? Understanding this. Okay, I think this has helped us too. I think I am missing a step here, but I will refer my notes and come back. It was a good session. I think I am going to stop. Or right in this text, it is working correctly. Okay, so this is the basically experiment notebook that was there in our notebook.experiment IPYNB file. Let me search here. History. See here only we okay. So we are naming this history, but where are we using this? I will come back, check this and come back in the next time. But it was a nice stream for day one. I'm not like I'm not like a veteran in this field, but still I will make sure that I will come back with um I will come back with another part of this particular stream. So thank you for joining today, whoever has. And if you like the stream, please put like and share it if you feel that it was good and I should keep doing these streams. And I will see you guys. I am going to continue this project again, and I will see you guys next, where we will modularize the experiment notebook that we uh, studied today. Bye bye. Have fun. Enjoy your weekend.